at solving problems with permutations with restrictions. These can get quite tricky, but I think the key thing is to keep it logical, to keep it as simple as possible, to follow some key guiding principles. And that's what I'm going to try and spell out in this particular video. We're going to look at a lot of examples, and hopefully the variety of examples will help us develop an understanding of some key types of questions that keep on popping up, that you keep on seeing. So this is, I guess, my key. If you take anything out of this video, a very, very important counting principle is to deal with the restrictions first. Always, whatever the restriction in the question is, deal with it first, and then you can deal with the rest of the stuff after. If you don't deal with it first, you often fall into problem, despair. So deal with the restrictions first. It's probably the number one thing to do with the restrictions. Deal with the restriction first. So here we go. So first question. How many 3-digit numbers can be formed using 1, 4, 6, and 9 only once, so that the number is odd and is greater than 400? So only once means I'm not repeating. Okay, without replacement. 3-digit. So what first thing we always do is set up, I know it's a 3-digit number, it's got to be odd. So what digits can go at the end? That's my restriction. So deal with that first. First thing I'm going to do is odd. Well, look at these numbers. It could be a 1 or a 9. So there's two options there. So now I've used one of those two options up. So I've got one less number. I've got how many digits left to fill out in this first spot. Okay, well, I've used one of these 4 digits up, so I've got 3 digits left out of those 4 digits for that position there. So 3 for there, then I've used that up, so then I've got 2 left. So 3 times 2 times 2, which is 12. So B, I want it to be greater than 400. In order for it to be greater than 400, the restriction must be on the first digit. It can't be a 1, right? It can only be a 4, 6, or a 9. So there are 3 options for the first digit. Then I've filled out that spot. So that one spot's gone. How many numbers will I have left? I'll have 3 digits left. And that can go there. And then I'll have one less 2 digits left there. Okay. So that's 18. Notice we deal with the restriction first. Repeat the above a question allowing for repetition. So rather than only using these digits once, I can use them as many times as I like. So once again, I always deal with the restriction first. Is odd. It's either going to be a 1 or a 9. There are 2 options there. But then I can repeat. So I can use any of the 4 again. So I can use any of the 4 to fill out the first. I can use any of the 4 to fill out the second there. Okay, so when I do that, I get 32. B, greater than 400. So once again, I can only start with a 4, 6, or 9. So there are 3 options for that first digit. But then, because I'm allowed to repeat, I've got 4 digits I can use for the second place and the third place. 4 digits I can use for that. So that's going to be 48 ways of doing that. All right, next question. Find how many arrangements of the letters of the word uniform are possible if M must be at the start and U must be at the end. So we're starting with an M. So how many letters is that? 1, 2, 3, 4, 5, 6, 7. 7 letters. So I'm starting, I'll have 1, 2, 3, 4, 5 in the middle, and I'll finish with L. I deal with the restriction, sorry, not with L, with U. I deal with that restriction first. There's one way of doing that, one way of doing that. Now, I've got 5 positions left to fill. I've got 5 letters to choose from as well. So that's going to be, you can either write it as well, it's going to be 5 times 4 times 3 times 2 times 1. But rather than writing that long expression out, you could write 5 factorial. Or equivalently 5p5. There's 5 and I'm picking 5 to arrange. So the answer is going to be 120 for A. B. If the vowels must occupy the first, the middle, and the last position. So I've got 7 positions. 1, 3, 4, 5, 6, 7. A vowel here, a vowel here, and a vowel here. Let's count how many vowels. Remember vowels. A, E, I, O, U. What vowels do I have here? I've got, how many vowels? 1, 2, 3. I've got 3 vowels. So that means I must have 4 consonants. Okay, so 3 vowels. So the first position, I'm going to have 3 options for that. Then middle 2, and then the end 1. I've dealt with the restriction first. And now I've got 4 consonants to fill 4 positions. So that can happen in 4 times 3 times 2 times 1 or 4 factorial way. So here this 3 times 2 times 1, I'm just going to write it as 3 factorial. And then I've got times by 4 factorial there. Okay. Notice even though it's not times in order, you can still split it into 3 factorial times 4 factorial. Okay, there's your 3 factorial. And there's your 4 factorial. Okay, and when you do that, 3 factorial times 4 factorial is 144. Next. If the vowels and consonants alternate. So alternate means one and then the other. Okay. So we've got 4 consonants and 3 vowels. 7 spots. 1, 2, 3, 4, 5, 6, 7. Now, if you put a vowel at the beginning, you would run into trouble when you're alternating. Don't write this, okay? Because if you put the vowel at the beginning, you'll see there's 4 vowels and only 3 consonants, so that doesn't work. So when you alternate, begin with the one that is one higher. So therefore I'm going to begin with a consonant, and then a vowel, consonant, vowel, consonant, vowel, consonant. See, 4 consonants, 3 vowels. Fits nicely. Okay. So that's going to be, there's going to be 4 ways to fill that. 3, 2, 1. And likewise for the 3 vowels, 3, 2, 1, multiply it out. You're still going to get 4 factorial times 3 factorial, aren't you, for this particular case? Okay, so that's 144 again. D. If M is somewhere to the right of U. Okay, whenever you got one of these ones where something is to either the left or to the right, the key thing that you've got to logically understand is that half the time, half the options M will be to the right of you, and the other half of the options M would be to the left of you. So the key thing, whenever you've got something to the right of something or something to the left of something, you do half the total number of options. So the key thing is you're doing half the total number of options. So we've got 7 letters. The total number of arrangements of those 7 letters in 7 positions would be 7p7. 7, I'm picking 7, and I'm doing half of that. Okay, which is going to be 2520. Okay, so, or another way of thinking about it is 7 objects, 7 positions. How many arrangements is 7 factorial? Okay. Okay, I prefer to use the factorial notation. Okay. Next restriction type we're going to have a look at is grouping. This is when certain things need to be next to other certain things. Okay, so when you're doing this, we order the groups and we order the individuals within each group. Okay, remember to deal with restrictions first, and remember, and when you're grouping stuff, you can group one thing. Okay, you'll see that in a moment. So I'm going to explain the logic using an example. So how many arrangements? So we're looking at ordered. Whenever you see arrangements, ordered selections, that's what you're thinking. Of the letters of the word Olympic are possible if C and L are together, and it says in any order, so it can be C, L, or LC, doesn't matter. So the first thing we do is that C and L have to be together in a block. We put a block there for C and L. So let me count how many letters we got. 1, 2, 3, 4, 5, 6, 7. 7 different letters. Okay, C and L are together in one block. That means that, because there's 7 letters altogether, there should be 5 other letters. 1, 2, 3, 4, 5. I'm going to block them out. So this bit will be for C and L. C and L can be arranged in this block in 2 factorial ways. 2 times 1. Yep. 2 for the first position, 1 for the second. And then what we do is we rearrange all these group blocks. Okay. So one of these will be like O, one of them will be Y, M, P, and I. And what we do is we arrange all these blocks. So 1, 2, 3, 4, 5, 6. We've got 6 factorial blocks. 1 less than the letters that we've started with because we've paired 2 of them together. So this first 2 factorial is for the pairings of the C and the L, switching their order around. And the 6 factorial comes from the fact that we've got 6 blocks there. Okay, so when we do that, we get an answer of 1440. Next one. So we got Barbara, John, 6 other people. So that's altogether 8 people. Go through a doorway 1 at a time. How many arrangements can be done if John goes through the doorway after Barbara, but no one in between? So that's my restriction. I've got to deal with that first. So John goes after directly after Barbara. So that means that we have to have B first, then J second. Okay, so there's only one way for that and one way for that. So that's the individual inside that group. How many options? 1 times 1. We can't switch it like this one, so we don't have a 2 factorial. We just got a 1 times 1. So that's Barbara and John done. We've got 6 other people. So I'm going to call them 6 other groups. So how many groups have we got? We've got 1 with Barbara and John, and we've got 6 other groups. So we've got 7 groups that we need to rearrange. So how many arrangements? 1 times 1 for Barbara and John. And then 7 groups, so 7 factorial. And we're going to get 5040. Alright, next one. These, for examples, are good. If you understand these, that'll really help your grouping. In how many ways can 5 boys, 4 girls be arranged in a line if the boys and the girls are in separate groups? So boys next to boys and girls separate. So there's 2 separate groups, boys and girls. It doesn't say which groups first, so we can switch them. So I've got 1, 2, 3, 4, 5 there, and 1, 2, 3, 4 there. So how many ways can the boys rearrange themselves? 5 factorial ways. 5 boys, 5 spots, 5 factorial ways. What about the girls? 4 girls, 4 spots. So that's going to be 4 factorial way. And then we can also rearrange the groups. There are 2 groups, so the groups can be arranged in 2 factorial ways. Okay, so that's how you do the first one. 5, 7, 6, 0.